Okay, today is March the 1st, 2018, and right now at 7 p.m. we're looking at the SSEC Goes East map. This is the mid-level tropical water vapor loop, which is 6.9 micrometer in wavelength. This east coast, the Goes East, has been split up into three different maps for each of the IR, the visible, and the water vapor as well. So the infrared, the water vapor, and the visible that have been split up. And right now we're looking at a tropical flow. This is a warmer flow coming out of the tropics, and that is moving right towards this developing storm right up here. And we can see an angle, actually a right angle right there forming. So there is a transmitter in the act right here, and that's going to cause a lot of trouble, a lot of wind in the path of this storm, which is going to be right pretty much due east. And also there's quite a few low pressure systems. Let's take a look at the East Coast Atlantic Surface Analysis map right here, and we can see that I'll pan over a little bit, and we can see the situation right here. We've got this rapidly intensifying storm right here, which is 999 millibar right here in this area. This is moving due east. But look at all these lows in the path of this system, and also we've got that transmitter, which is boring high pressure right into the back side of this. So we're going to see a lot of tornadoes in this area as this moves to the east. So let's go back to the map again and take a look. And once again, we can see the transmitter at work. This dark area right here, generating that right angle, is forcing high pressure into this system. Now, the excuse that can be used is, well, we're going to prevent this system from developing and intensifying. But in fact, by forcing high pressure into this system, that's just going to cause a lot of wild weather. In addition to in the path that this is moving, plus you have all these lows in this area, and that's not going to help. So we're going to see a lot of probably tornadoes, wind, and a lot of rain and snow. Let's go ahead and take a look at the Doppler map here right now for the East Coast. We can see the right here. We can see the situation. Basically, we have a division here. We have the warmer tropical flow. Zoom out one click here. We have the warmer tropical flow all through here. Let's go back to the map and take one more look at it. We can see this warm tropical flow right here. And right above this line, we have the much cooler air moving down from out of Canada and through the Great Lakes area. So, where was I here? Right here. Okay, so we can see the division. The warmer air is down here, and we have that colder air. That's going to mix, and of course, we've got the high pressure being forced into the area. That right angle is right in this area, and that's going to cause a lot of additional problems. So that will amplify, if anything, that will amplify the effects of a severe storm. And we're going to see tornadoes and all that. So now out here on the west coast, we can see that rain is moving down through San Luis Obispo towards Southern California. And we can also see those microwave Doppler, the NEXRAD WSR 88Ds at work. We can see some straight edges up here in the Oregon area. Right up in this area, we can see a lot of see that precipitation being chopped up by the ground-based microwave Doppler radars, which are masquerading as Doppler radars, but in fact they work dual function. And as we can see, there is some rain falling right now near Paso Robles and King City, Salinas. That's all supposed to move south. Let's take a look at the map here for the west coast. Zoom in a little bit, take a look at that. Okay, so we have the northeast Pacific water vapor loop right here. And this is a 989 millibar storm system. Let's go ahead and look at the West Coast? Here it is, right here. Okay, so this is the West Coast surface analysis map. 989 millibar storm right here. And what do we see? An occluded front, which is a warm front overtaking a cold front right here in the middle of this storm. So ask the climate change people out there that are peddling the CO2 argument how this can be. How do we have a warm front right in the middle of a storm? This is all moving to the southeast, right down the coast towards Southern California. We have a high here, but we also have other low pressures. We've got 3 lows in addition to this storm, and a gale right down here. A couple of troughs are shown. And so we're supposed to have some rain starting tonight, Thursday night, and going all the way into Saturday. If we look at this map again, we can see the storm right here. This is moving to the south. We also have another developing system out here near the Hawaiian Islands. This is being manipulated. We can see a straight edge, right angle forming. Here in the infrared loop, we can see that a storm, that occluded front is causing a separation up here. Let's take a look at that in the look at this in the color infrared map right up here. So there's a transmitter at work right here causing that feature, which is preventing this portion of the moisture from wrapping back around into that vortex. So they are throttling the system, and we can see that right here. We actually have a transmitter at work, that dark area. Looks like a small little right angle, a rectangle right there. Okay, so that is pretty much the situation. We're expecting rain. We only got 1/3 of an inch last Monday, and a little bit of snow in the Verdugo Mountains. The tall mountains behind the Verdugos got some snow. The 5,000-foot mountains along the San Gabriel Range. But that was about it. So we'll see what happens. We're expecting maybe 1 inch of rain upcoming the next couple of days. So that's all good. So we'll see what happens. Okay, that's it.